that's 230 feet. And then if you go 15 feet above that, there's an 80-meter dive pole at 245 feet. And then there are 3 more 20-meter beams, one down at the next guy level at 170, then 110 feet below the lights, and another one at 50 feet. There are also 2 40-meter beams on this tower. They have the T elements. Those are Moxons, which actually do linear, or they do loading so that the elements are physically shorter than full-size elements. The full-size 40-meter beams are on the 40-meter tower, and we'll see that here in a few minutes. And this is 8 elements. This is an 8-element stacked array of 4 10-meter Yagis. So they're on 50-foot booms. It's the same idea as we have on 20 meters with the 6/6/6. It's 8/8, starting at 135 feet, and then the low one's at 33 feet. Interestingly enough, in a couple of weeks when the DX contest is on, and we're working Europeans, which is that direction, the bottom antenna by itself will be the best antenna. That's how this works. When you have high sunspots, you want to get in to the highest angle. And so we will shut down those 3 and just use the bottom. That'll be the best. And it'll be very evident when they're switching that antenna is the best to Europe. We work more Europeans. We work about 75–80% Europeans. Starting at 160 feet and coming down 7/7/7/7. And on top is a 6-meter beam. It's 10 elements. Actually, it's 9.5. You'll notice one of the directors is missing half the side. That's at 175 feet. And I use that primarily for finding noise. Finding noise is very important, whether it be in somebody's house or power line. And when it's not being used by me to find noise, it's being remotely controlled by my friend K3Lr in Pittsburgh that he's using it today to work into South America on 6 meters. 6 meters this winter is going to be unbelievable. It will have propagation to Europe on a daily basis. So he's worked 150 countries on 6 meters with 200 watts for them antenna. So it works very well. But you see the same idea. In the middle is a 5.8 gig dish that's aimed on our local repeater. That's how we get internet for D-Star and control the repeater. It doesn't make sense for our club to pay $50 a month to Spectrum when for $700 we got a link. And that takes care of the internet. World's largest 20-meter array. This is the world's largest 40-meter array. At the top of the tower is a 4-element 40-meter beam. The reflector, which is back towards us, is 75 feet long. And then there's another one down at 190 feet, and another one down at 120 feet. Each one of those 40-meter beams weighs 410 pounds.
Holy cow.
So they're very heavy antennas, and they... And so it's 4/4/4 on 40 meters. And then there's 4 10-meter Yagis on that tower. Top 10-meter Yagi at 275 feet, and then one at 215, and then 2 at 80/50. And then 2 20-meter beams. There's 138 square feet of wind load on one tower, properly engineered. About these 4 squares. This is a 4 square for 80 meters. So these 4 towers work together, and then there's another one over there, another 4 squares. The 2 4 squares work together. It's broadside on Europe, so it's basically a stacked array of verticals towards Europe. These can be rotated electronically in 4 different directions: 45, 135, 225, and 315. You can see the radials. There's 120 radials under each one of the towers. are aluminum towers. They're made in Michigan by Universal Tower. You can see there's insulators on the bottom. These are 80-meter full-size verticals. They're 60 feet of tower and then about 10 feet of stinger to make sure that they're tuned at the exact same frequency. Up front, my neighbors keep asking, when are you going to finish that tower? Well, it's done. That's the 160-meter vertical system. So the tower is the driven element. On the top of the tower, you see 4 support lines. They go to T-wires that go to these control boxes. And that is it's a 3-element vertical array. It's a parasitic gag, 3 elements on 160 meters. It can be rotated in 4 different directions by using relays at these bottom switch boxes. It also has a whole radio field of its own. So that's an outstanding transmitting and receiving antenna for 160 meters. It's a 4 square for 20 meters out by the stop sign, and a 4 square on 10 meters just in front of that by the road.
It's like AM broadcasting, the towers.
Yeah. And these,
yeah.
DX Engineering Skyhawk with the DX Engineering rotator. The Skyhawk is the same antenna that we have at DX Engineering. That's an antenna that I designed, co-designed with WA3FET 25 years ago. But we use that for receiving in-band, but across the street away from all the other stuff here. So, gives you some idea of that. We go back to the corner of the company. They run very efficiently that way.
I'm sure you're not waiting on a NetLogger server to
Nope.
respond.
No. I mean, can you imagine? There are multi-op stations that everybody brings their radio, they bring computers, they try and set it up on Friday afternoon and try to make it work Friday night for the whole weekend. It never works. Even on field day, it's tough. Everybody bringing different equipment and different stuff. So they don't have to bring anything. The headphones are here, the keys are here, the mics are here, everything is here. And so it's all well tested, and I know it all works together.
So what kind of logger do you use?
That was my question.
Wind test.
Wind testing.
Wind test is somewhat like N1MM, only it has a different layout to it. It's written by French rocket scientists. I've been using it since 2006. It's very popular in Europe.
Intel Nook.
And because these are scientists that wrote this thing, it's bulletproof. We can take a load on Thursday night and I know there's no bugs.
Hospital on the highway on that, huh?
Well, when you're doing contesting, is everybody using headset except for the other guys? Yeah, headsets.
Oh,
Well, let me ask you this question. I have a 10DA and a stand, a static stand. I want to put it in my 7300. That's doable, isn't it?
it is doable, but the interface cable has to be changed. It is doable. You'll see.